All right, this is AP Calculus. We are on lesson 7-5. This is the worksheet, and these are the answers. Today's date is Friday, January 10th, 2020. Know that the speed is absolute value of velocity. Increasing means they have the same signs. Decreasing means they have the opposite signs. And total distance is the absolute value versus the change in distance, which is non-absolute value. All right, so we have this graph. A bug, again, is crawling up a vertical wire, so I could do another horrible picture, but I'm going to forgo that. Is the bug's speed increasing or decreasing, or is it increasing at time is equal to 1? So at time is equal to 1, I'm at this point. And this is a graph of velocity. So acceleration, I'll put it over here, acceleration and velocity. Velocity is height, and acceleration is slope. So the height and slope are both positive in this case, so it is indeed increasing. And let me make this a little bit nicer looking, and I can come down here and type in a color. I can say the bug's speed is increasing at t is equal to 1 because v and a are the same sign. Next, is the bug's speed increasing at time is equal to 7.5? So at 7.5, that's right here. There I have a negative height, so velocity is less than 0, and the acceleration, the slope here is positive. Acceleration is greater than 0. I could put this one here. A is greater than 0. V is greater than 0. This one has opposite signs, so it is actually decreasing down here. So if I come down here and type, we can say that the bug's speed is decreasing at t is equal to 7.5 because V and A have opposite signs. C, what is the total distance the bug traveled? So all I have to do is add up all of the area, treating this area as positive. I take the absolute value of the area. So if I divide up this triangle, it is a 2 by 3, which is 6, but half of that is 3, because it's half of a triangle. This is a congruent triangle, so that's 3. This is a rectangle that is 2 by 3, which is 6. This triangle down here, this whole triangle right here, has a base of 2, a height of 1. 1 times 2 is 2, and then it's half of that because it's a triangle, so this has an area of -1, but it is absolute value of that, so it should be a positive 1. So the answer down here is 3 plus 6 plus 3 plus the absolute value of -1 is equal to, well, that's 9, 10, 11, 12, 13. On to the next question. I will need my calculator for this one. Let's pull up my calculator, clear out of that. We're all good. So we have a particle moving along the x-axis. Here is its function. I imagine I need to plug that in. Let's go ahead and do that now. Y is equal to, get rid of that guy, get rid of that guy. We have the natural log of, we have x quantity squared, or just x squared, minus 3x plus 3. All right, I have my function in here correctly. What do I need to do now? Is the particle speeding up at time is equal to 0.5? Well, I need to graph that then. So my window is between 0 and 5. So window 0, enter, 5, enter, and zoom 0 to zoom to size, or zoom to fit. That's graphing. So we're going to look at time is equal to 0.5. So this is new information for all of us, so please pay attention, which is, how do I find t is equal to 0.5? Go to trace. Trace. If I type trace, then I can go to any value that I want, hit 0.5, enter, and it is tracing 0.5, and that is the end of your new stuff. So I can see that at 0.5, my slope is negative, my height is positive. Those have the opposite signs, so it is not speeding up. So I come back over here, and I type in the particle is not speeding up at t is equal to 0.5. And the reason is because V and A have opposite signs. All right, is the particle slowing down at t is equal to 1.2? So I come back over here, I trace 1.2, I hit enter, and I see that I'm below the x-axis, or below the t-axis in this case. So I have a negative height, and my slope is still negative. I haven't hit this point yet. So they have the same sign. Let's go ahead and type that down here. If they have the same sign, it should be speeding up, which is not what it says. The particle is speeding up, so it is not slowing down at t is equal to 1.2 because v and a have the same sign. All right, what is the total distance traveled? This one I'm going to need my pencil, I think. Over 0 to 5 seconds. So total distance, I need to take the absolute value of this. What just happened? It just died. It just went away for no reason. Come back. Oh, okay.
It's karma because you got mad at Mr. Brown.
Is that what it is? Sorry, Mr. Brown. Wabbit, EMU, open that back up. I have to regraph this thing. Oh no. So file, open recent, the TI-83. I have to come back to y equals, regraph this thing. Natural log of x squared minus 3x plus 3. And then what I'm going to do now is I'm going to ungraph this by hovering over the equal sign and hitting enter. Come back down here, math right, enter, absolute value of vars right, enter 1, my y1 variable. And I could graph that, but an even faster way to do that is just to do it without a graph. Since I'm already taking the absolute value, I can come to second quit and I can do math 9 to find the integral of vars right, enter 2, because it's y2 in this case, with respect to x from 0 to 5, so I know, ignore, from 0 to 5, and I'll get my answer. I'll also show you how to do that with a graph in case you only want to do a graph, but this way is a little bit faster. It does take a little bit longer than a normal function because absolute value functions are a little bit weird on the calculator. I don't know exactly how they work, I just know that they typically take a long time. Again, if you don't like how it's loading forever and you want to switch it up, hit on and it will stop the calculation. I think that's the only way that you can stop the calculation. Clear will not work. Go calculator, you got this. Oh my gosh, it is taking its sweet time. 5.112. 5.112 and no units. So that's the answer. How do you do that with the graph? Well, I go to zoom 0 and it will only have positive numbers if it will work. You'll see that little bump over here. Bump. It is a tiny little bump. Wait, no, my window's all off. 0, enter, 5, enter. Try again. Zoom 0. I forgot that I had to close out of this calculator. And it's going to try again. Yes, I do have that bump that I was looking for. That would have been below the t-axis, and then I have all that. And then I can do second trace to calculate. Second trace, 7. My lower limit, 0, enter. Upper limit, 5, enter. And then it will shade in all of the same stuff. It still takes a bit of time. And I should get the same answer of 5.112. Oh my gosh, come on, calculator, you got this. I know it's a natural log function. I know you have an absolute value function. There it goes. All right, you guys are dismissed. See ya. And 5.111. Interesting. That last number is a little bit off when you do the graph. So I can see that, or 5.111. All right, so coming back, the squirrel's speed is the squirrel's speed increasing at time is equal to 4. So at 4, the squirrel is right here. This is a graph of velocity. It says so down here. So we know that the velocity is positive, but acceleration is 0. So if the acceleration is 0, then I'm not increasing or I'm not speeding up. I need them to have the same sign, and if there is no sign, that's not the same sign. So this one is kind of a weird case, and I didn't really cover it in the notes as well as I could have, but the answer here is no. It is not increasing. So no. I can't spell out. Squirrel's speed is not increasing at t is equal to 4 because V and A are not the same sign. More specifically, the acceleration is equal to 0 and the velocity is greater than 0. So those are not the same sign. Question B, is the squirrel speed increasing at time is equal to 8? So over here at 8, let's come over here and make a point. So my velocity here, I can make this here as well. Velocity was greater than 0, acceleration was equal to 0. The velocity here is still greater than 0, the height is greater than 0, and then the acceleration, the slope here is negative. So these are opposite signs, so you know that you are decreasing in the speed. This is asking, is the speed increasing? No, it's decreasing. I just said that. All right, so this one again is no. The squirrel's speed is not increasing at t is equal to 8 because V and A, I forgot to put the A up here, Just kind of reading it. V and A are not the same sign. V and, come on, I just want to add this one. V and A are not the same sign. And now I messed this one up as well. There it goes. Part C, what is the total distance traveled? All right, we got to do some geometry area calculations. So this is going to be a 2 by 20 rectangle. 2 times 20 is 40. Divided by 2 is 20. So we'll write down 20. This is going to be a rectangle here that goes from 2 to 7. So that's a total distance of 5. And then 5 by 20 is 100. So 20 plus 100 plus, and this is a congruent triangle as well, so it should be 20. Again, it's 2 by 20, so plus 20 plus, okay, so now I have a negative area down here, but I'm going to take the absolute value since it's total distance traveled, not total position change. This is going to be a 10 by 1 triangle, so 10 by 1 is 10, and then divide by 2, this is a negative 5. So I take the absolute value of negative 5. Plus, and then this is going to be a 1, 2, 3, 4 by 10 triangle, so negative 40 here. So I need to take the absolute value of that, negative 40, plus the absolute value of this is going to be negative 5 again. It's a congruent triangle, negative 5, which will turn into a positive 5. And then finally I have a triangle that looks the same as this triangle and it's 1 by 10, and then divide by 2, so I get 5. Put negative 5 there. That is a positive 5 there, so plus that positive 5, and then finally plus this rectangle, because it goes all the way out to 18, make sure I didn't make a mistake, all the way out to 18, this is a 2 by 10, this is a 20 area. Alright, so adding, and you do have a calculator, no you don't have a calculator for this one, okay, so 20 plus 100 plus 20, that's 140, let me make a note to myself that that is 140, and then I'll do some other math over here. 5 and 5 and 5 is 15, plus 40 is 55, and then 75. So I have 75 over there. And then adding those two together, I get 215. Is that right? 215. Hopefully I didn't make any math errors, but if I did, it's just your extra credit point, right? And then I haven't been numbering these questions. This was really number 3. This was number 2. This was number 1. And then I'm finally on number 4, the second to last question, I think, right? Yep, second last question. This is number 5 down there. Oop. 5 right there. Number 4, car traveling on a straight track. We know our window between 0 and 60, and we need to just use appropriate units to explain the meaning of that. Okay, so we've seen this before, but now absolute value. So we'll say that, I'll give some room to actually write this, but we'll say that that thing means the total distance traveled in feet, so I'll do in parentheses, in feet, from 30 to 60 seconds. And I'm going to scooch that over here a little bit so I can say that this integral, I'll rewrite the integral, between 30 and 60 of the absolute value of Vt. Okay, I'm going to have to move this over more, aren't I? And then rewrite this to make it a little bit bigger. Vt dt, that thing means the total distance traveled, and I can make that match up nice and perfect. All right, and using the correct units, explain the meaning of this thing. So I'm going to rewrite that first so I don't make all those mistakes. This thing from 0 to 60, the absolute value of Vt and the absolute value dt, that thing, and then using this, means the total distance traveled. What are our units? In, where am I not seeing? Oh, measured in meters. Okay, in meters from 0 to 60 seconds, I'm gonna guess. Seconds, yeah, seconds right here. Perfect. And I can move this nice and close. There it is. And that concludes worksheet 7-5.